Chief, do you mind telling me what you're doing in that printer?
Sir, finishing this print.
What's up guys, I'm Jacob with Butter Pockets, and today I want to tell you about Vorons, and more specifically, this Formbot Voron 2.4 Pro Kit. Now, like I've said in other videos, I get on the internet, I see the YouTube comments, I see your little Reddit posts. Why would I build a Voron when I can just buy an X1 or insert other printer here? Well, you know what I have to say to that? Self-built printers fulfill a nice niche in the market where if something breaks or you want a different component, you want to add an LED, you want to add a heater, you want to do literally anything you want, well, you can do it because you built the printer yourself, you have full access to the firmware, and you're not beholden to any other company except you and your wallet. And if you're following the ideology of the Voron design team, it's all off-the-shelf components, so nothing is custom made. Now, when you follow the Voron documentation like you're supposed to, like I said, everything is off the shelf and you should be able to buy it all. And if you don't want to go through that entire process, you have the option to buy a kit, which is what I did. I reached out to Formbot and they gave me a discount on this kit so I could build it for you guys. When you opt to go with a kit, a lot of the times the kit will come with things that the Voron documentation doesn't explicitly call out, or sometimes it comes with certain upgrades or mods like this one does. And if that's the case, you can't follow all of the documentation for the 2.4 exactly to a T. So what I want this video to be is kind of an instruction set for this kit. Formbot has a few instructions on their page for this kit, but I wanted a one-stop shop kind of thing where you can come watch this video and everything you need to put this kit together is included. I've actually built another Formbot 2.4, and when I first did that one, there was actually very limited documentation on their website, so I'm glad to see that they've updated it. So with all that out of the way, I want to jump into how this kit kind of differs from the standard Voron documentation, tell you the parts that you're going to need to print specifically for this kit, and tell you some of the parts that you won't print for this kit, tell you some of the stuff you need to buy, and what I bought besides what came in the kit. I want to go ahead and give you guys a list of the parts that you're going to want to print or not print, so that way if you print your parts before you start your build, which you should, is what I did, you know what to do. So you're going to want to print the BTT HDMI 5 mount. You're going to want to print the nozzle brush mount if you're going to actually mount the brush that comes with the kit at the back of your plate, so that way you can clean your nozzle at the beginning of a print. The PG7 mount for your gantry, the Y end stop relocation for your gantry, and I'm going to include two links for this because the one that Formbot has, the one that I used, there's actually a little bit better one, and I would probably recommend that. The stealth burner main body for SB2209, you specifically need to print the step file that is in the GitHub, not the STL, because it is wrong, and you will not print the normal stealth burner main body. You want to print the cable cover for PCB, which is also from BTT. You want to print the tap printed parts. You want to print the M8P mainboard DIN rail mount. The annex panel clips, if you plan to use the annex panel clips, you don't have to, you can stick with the Voron regular ones. The parts for your Nevermore V6, the gantry installation hooks, which I'll show off later in the video. And then you want to print these optional files, which you'll find in the Voron files. So in the main 2.4, you'll see a tools folder. You definitely want to print the MGN9 rail guide, the MGN12 rail guide, and the pulley jig. In the stealth burner tools, you're going to find the 5015 cutting jig A and B, definitely print that. In the stealth burner, they're listed as O, I believe that's for optional. The LED carrier and the diffuser, go ahead and print those. You will need clear filament, I used PETG. And for tap, you definitely want to print the MGN9 assembly tool. The Formbot kit comes with a little rail guide to slide the carriage off. I find that the one from Voron works a lot better. I'm going to have everything I just mentioned linked in a document that you can find in the description. I also want to say that this video is sponsored by PCBWay. So if you are looking to do a project and you don't have all the tools necessary to finish it, whether you want a PCB fabricated or something 3D printed or additive manufacturing, CNC'd, PCBWay has you covered. I actually have some parts here that I had them SLA print in nylon glass fiber that I'm going to install, and this is for the tap installation, so I'm hoping that the nylon glass fiber is a little more rigid than ASA, and we'll see if it changes anything in the input shaper graphs. But either way, if you need something for your project to make your dream project a reality, check out PCBWay with my link below and you can get $5 off your first order. So stay tuned for when I do these parts later on in the video. And with that, let's jump into the build. We've got our box, so let's go through what is inside. In the top, we have the panels. I already removed the bed. This should be in the bottom. Then we have all of our electronic components and wires and fasteners and stuff like that. And then we have our milled bed and our bed heater. And then we have the frame, the motors, and some other little bits and bobs. So let's go through this, show you what's in the kit, and kind of what separates it from the other kits that are on the market. So let me cover some things that I think kind of set this kit apart from other kits, and just some nice features that this kit has. So it comes with the M8P and CB1 combo for the main board and the Raspberry Pi. You know, the CB1 is a little underpowered compared to like a Raspberry Pi 4, but I have one in my other Voron, and the only complaint I really have is that the frame rate on my camera is a little slow. It comes with a nice 5-inch touchscreen. It comes with a complete tap kit, so the rail is already cut. It comes with the sensor. It comes with Moon's motors, which I really like. And although these motors are made specifically for this kit, you do get the data sheet that you can reference. It comes with a nice precision machined bed. This thing is very flat. It's not Mandela Roseworks, but it's really good for the price of this kit. It comes with a knockoff Bondtech IDGA kit, the integrated direct drive gear thing. It comes with everything you need for the Nevermore filter. It comes with injection molded parts for the fume extractor on the back. And it comes with this 3N 6-out PCB, so you don't use WAGO connectors to do your mains voltage wiring on the bottom. This is probably a better option. Before we begin building, I want to cover some things that you're going to need to build a Voron. First thing is going to be a set of hex wrenches. I have 1.5 millimeters through 3, and then I have my LTT screwdriver that has all the rest, and I have an iFixit kit. Whatever you have, just some kind of kit. If you have L-shaped ones, that's fine, as long as you have all the sizes that you're going to need. But you're probably going to want some various ones in different lengths or whatever, so that way you can reach all the screws that you need to, or all the fasteners that you need to. You're going to want some flush cutters, any will do. You might also want something that's a little stronger than flush cutters. Like for instance, I have my Leatherman, and this can actually cut like steel wire, which in this kit is included, so keep that in mind. You're going to want a soldering iron. You're going to want a scale or a ruler, however you would call this. You're going to want probably a couple sizes of these. You're going to want some calipers. I recommend digital ones. These are just from Amazon. You don't have to buy like super expensive ones. They don't have to be the most precise ever in the world. You're gonna want some grease. I just have this syringe filled with EP2. This is for cars, but this is what a lot of people recommend for 3D printers. You're gonna want some IPA, some isopropyl alcohol. This is, I think, 90% IPA, 99%. I got this on Amazon as well. You can probably find this at Walmart or CVS or wherever. Just try not to go for like the 70%, try to get 90 and up. And I think that's everything you would need. So let me cover some things you might want. Beyond that, you're gonna want a flat surface. I picked up this granite slab at like a granite recycling place near me. They take like broken countertops and stuff and recycle them. I got this for like $5. Check around you, see what's available. You might be able to go to a hardware store and get like a counter sample or something, a flat mirror some people recommend. Whatever you have that's flat, use it. Some clamps. I'm gonna take a page from Steve Builds, and that's how I'm gonna put my frame together. I've done it by hand, and it's really annoying. You're gonna want some 1, 2, 3 blocks. You can also just get those at your local hardware store. I ordered these on Amazon. These are like 90-degree aluminum brackets that I'm gonna use with the clamps and the 1, 2, 3 blocks to put the frame together. These were relatively cheap, and I'll have links for all the relevant stuff down below. I definitely recommend these with the clamps to do the frame. I've done it by hand, it's super annoying. Besides these 90-degree brackets, you can also get like a machinist square, but these are kind of annoying, especially because there's a difference in the edge. These aren't like perfectly flat on the whole outside like these are. So while these can be useful for checking squaring, they're not useful for like actually putting the frame together. Probably will want some wire strippers. They make better ones than this, but these work. You will probably want a JST crimper. You can get this on Amazon too. It's iWis. It works. I've done every type of connector, whether it's JST or otherwise, and this thing has worked for me. You'll probably want some super glue. This should probably be in the need, but I don't know that you need it, but I would definitely get some. Some other things that I don't really have right in front of me, but that you'll also probably want are like electrical tape, heat shrink, and a lighter or a heat gun, and a couple different types of tweezers or whatever, maybe some pliers, whether you have needle nose or like just short little tweezers, something like that. And then to go with your soldering iron, an actual tip that is meant for heat inserts. You don't have to have one of these, but it makes it a lot easier. So now that we've covered what you're gonna need to put this thing together, let's go ahead and put it together. And I'm gonna start with the frame. Following the official instructions, the first step to putting the frame together is putting your A and B extrusions together. And I'll link a Steve Builds video where he shows this, and there's other videos on the internet that show this, but using these clamps and these angle brackets is by far the easiest way to do it, especially if you have a large flat surface like this. So let's grab A and let's grab B. We'll slide them together and we'll kind of get the screws started, fastener started. We'll put our angle bracket in here in the corner, put our 1, 2, 3 blocks on the sides, and then we'll give her the clamps.
The clamps! Right?
And then we'll tighten it down. And then we can check our work with something like a machinist square, and it looks pretty 90 degrees to me. We'll measure it when the whole frame is built together, but that's how I'm going to assemble all these pieces together, and then I'll get back to you guys when the frame is built. And as you can see, the frame is built. You can double check your squaring by measuring from corner to corner on all 6 sides. I did that and I confirmed that it is square, so we'll move on. And make sure you don't just install the rails as they are. You need to clean them first, so hit them with like a degreaser, like brake clean, and then soak them in some IPA to get rid of that. And then you want to make sure you grease them, which I'll show you here in a sec. So when greasing your rails, I've seen other YouTubers, I've had friends tell me to use the little syringe that comes with these, or the needle that comes with these syringes, and kind of go in the side. And some of these carriages have like fill ports. I can't really ever get that to work. The wiper just kind of wipes away all the grease. So the way that I've gotten this to work, I forget which YouTuber showed me this. I'll link a video if I figure it out. You get the carriage over 2 holes. You plug one, and without a needle on a plastic syringe like this, you stick that in there, and then you just push down until you see the grease like overflow out the carriage. And I switched holes right there and kind of got it on all sides. Put your plunger back up because grease is just going to start squirting out. I'll see if I can do a zoom in on this. You can see that there's just grease like pouring out of the sides of the carriage. And at this point, you slide it around, you kind of grease the sides, make sure the whole rail's greased, and you do that a bajillion times to grease all your rails. When doing this step and actually putting your linear rails onto the frame, they say that there's a bottom gap, 3 millimeters is fine. I don't know if it's just my perfectionism or whatever, but regardless if it's 3 millimeters or not, I want it to all be the same. So I literally just printed a piece that's 3 millimeters, and I just use that as spacing. Do whatever you want, but this works for me. If you are following along with the instructions as they are with the Formbot kit, you will skip this step. So when you get to this step where you're attaching your A and B motors to the gantry extrusion, I don't think it says this in the actual instructions, but go ahead and leave these 8 bolts loose. So that way when you check your gantry for racking, once you've installed it, they're already loose and you can just adjust these as you need to go. There's no point in having these tight right now. When you're installing your X-axis onto the gantry and you look at this step and it says only insert 2 screws, you're gonna insert all 4 because we're doing umbilical, your end stop isn't going here, so you can go ahead and put all 4 in. Remember not to tighten them all the way just yet. And remember to do them in an X pattern. So at this point, we're ready to hang the gantry, and we do that by installing the belts onto the gantry, and then we flip it up and install it into the frame. The best thing you can do at this point, and we'll do this for the XY axis as well, the AB belts, is to take all 4 of your Z belts, and if you don't have a kit, you're gonna have to cut them yourself. And even with a kit, you should check this. Make sure that they're all the same length. This will help your belt tension in the future. As long as all of them are the same length and you pull them all to the same one, you know you're starting with the same tension for the most part. And so the easiest way that I have to do this is to start with the belts at the same tooth and then move along them tooth by tooth, make sure not to misalign them, get to the end. And even here, I checked, they are off by, it looks like 1 tooth or 2 of these belts. So I'm just gonna align all the belts to 1 length. So I'll go through and I'll chop this extra tooth off. And I'll do so with all my belts and make sure they all have the exact same amount of teeth before I even start installing the belts. So when it comes to hanging your gantry, the instructions tell you to stick it in there and then use some zip ties to hold it in place. I found this model on printables and I'll link it in the description. So that way you can just hang it with something that you 3D print. Because I figure if you're going to try to use the zip ties, you probably need 2 people. And let's be real, we're all nerds, we don't know other people. So this is an easy way to do it by yourself. So go ahead and print these. And then once your gantry is already in there, hang it on one side. And there you go. Your gantry is hanging, and it only took one person. And so now that the gantry is secured by the Z-belts, we're going to take a page from Nero's book, and I'll link his video below to make sure that the gantry is not racked. And this is the first step at when you would do it. So that's why we didn't tighten these X-carriage bolts and why we left these bolts here on the X-axis of the gantry loose. That way we can make sure that these y-axes are parallel to each other, and it says this in the instructions. So with all those bolts loose, you move it to the back, then you can tighten these X-carriage bolts, and then you can run it to make sure the gantry is not racked, and then these will self-align, and then you can tighten these bolts back up. So once you have your gantry installed and you finish up those steps, the next thing, they'll show you a picture of what you're going to be doing, is installing your AB belts and your X carriage, because that's what holds the belts to the carriage. Now remember, with a Formbot kit, you have tap right out of the box. So you don't install the traditional X carriage, you're going to install the tap carriage. So go ahead and load up the documentation for tap and start to follow that, so that way you can install the right part, and then you don't install the traditional X carriage and then wonder, well, how the heck do I put tap on there? So at this point, you would start following the directions for tap, and you just follow them as they are. At this point, you probably have your tap X carriage installed, and things are looking good, and it's time to build your stealth burner. So when you start to build your Clockwork 2 and your stealth burner cooling section of it, I hope I mentioned this in the beginning, but there are some specific parts for this kit and the things that are included that you're going to need to print. So for instance, you're going to make sure you want to print the right parts for your hot end that you got. With this kit, you probably got a Dragon hot end, so print the right parts for that. And because you have your SB2209 toolhead board, there's specific parts for the Clockwork 2, such as this part that has some extra clearance for that, and the actual cover for this. So make sure you print those parts, and then as long as you have that, then you just follow the instructions for the Clockwork and the stealth burner as you normally would. I'm recording this on my phone, so hopefully you guys can see it. When installing your toolhead board, make sure you install the jumpers for your fans so that they're set to 24 volts. Make sure you set the dip switch for your PT1000. Install the jumper, I don't have it here yet, for your resistor. And then make sure you set out another jumper for this USB 5 volt so you can power it from a USB when you're flashing the firmware. And if you get the Formbot kit and you order the Dragon hot end, this part is going to come on top. You're going to have to undo the screws. I think they're 1.5 millimeters, so that way you can attach it to the actual toolhead mount for the stealth burner. All right, when you install your Dragon hot end, make sure you install it seemingly backwards, the logo facing the back, or else when you install this on the tap plate, the heat break will touch the plate here, and you won't be able, I mean, it'll probably melt this when you get it really hot, but this will leave room for this to be installed correctly. And if you install it backwards, you really can't fit the silicone sock, which is also part of that. So make sure you install it this way. Also be aware that these screws on the bottom of the stealth burner connect into the tap plate. There's a threaded insert that you did right here. So just make sure that these screws actually go all the way through and connect into this threaded insert. Now that I've got the stealth burner done, we've got this nice Master Chief theme going on. Hopefully you guys appreciate that. And if you're following along, hopefully you're at the same step and you were able to get all of this assembled as well. In my last clip, I talked about how you need to make sure that your tool head is the right way. And now that it is, this is very sturdy, even with tap installed. It really doesn't shake in any direction. So that's really awesome. And with that done, the next thing is electronics. So I'm going to flip this thing over, and Formbot does a really good job of labeling the wiring and everything. So if you just follow their diagram that they have for wiring on their website, it's actually really easy, but I'll go ahead and show it to you guys here in the next clip, and we'll get moving right along. And before we keep going, I want to point out that you should leave the cable cover unbolted, and you shouldn't attach your umbilical cable support just yet. Leave all of this until you're ready to actually install it. Makes it a lot easier. I did want to show you guys this. As of recording this, their documentation is kind of incomplete. So they tell you to put the jumpers here for all of the drivers and up here for all the drivers. And they note that your fans go here, but they don't tell you to set the jumpers here to make them 24 volt fans, and they won't turn on if you don't do that. And they don't tell you to set the jumper here for the 120 ohm resistor for CAN. So go ahead and make sure you set these jumpers before you continue. So I've made a lot of progress, and I really didn't film much of it because it's kind of boring, and you're really just following Formbot's instructions that are printed kind of on the cables. You can kind of see that they have labels, and following their wiring diagram. And like I mentioned before, something that their wiring diagram does not mention is putting the jumpers for the fans here and putting your 120 ohm termination resistor jumper as well. Another thing it doesn't mention is that for your CAN cable, it says like, hey, these need to go to 24 volts and this needs to plug in on here. And these are terminated as if they would plug in to like here, these posts, but they really shouldn't. They really need to attach straight to your power supply. So you need to put some ring terminals on these, which are not included in the kit. I guess this is something that you would need to buy or have. I happen to just have ring terminals, so I will crimp some ring terminals onto here and attach it directly to the power supply. You then would need to cut this heat shrink open to give yourself a little bit more room so these cables can reach. Now, another place that I kind of messed up is my PG7 cable glands. So I've already routed the cables here. The problem is the PG7 doesn't fit over that end of the plug. You have to put it on this end, which means that you would need to put your PG7s on, get them all the way down there, and then route it through the drag chain. At this point, I think I have everything in its final form. It's a bit messy. I could obviously make this a little bit more clean, but I tried to keep it as clean as possible with these cable channels. I did add a thermistor over here. I just happen to have one of these, so it'll be my chamber thermistor. Screen is wired up. The CAN cable is wired. I got my PG7 cable glands on and rerouted it through the drag chain. This should be a reference you can use for your build if you do a Formbot kit. Hopefully you can see everything that's plugged in there, and you should be able to at least have this help you out if you're trying to wire this yourself. I have the side fans plugged in, and I have the fan for the exhaust plugged in. What I don't have plugged in is the Nevermore, which would go here. I just haven't printed that yet. Now that the mechanical side of things is mostly put together, I added the PG7 mount back here, and I did the Y end stop relocation. I'll have links to these STLs, and Formbot actually links those on their website, which is nice. When I built my first one, they didn't have that, so it's good that they provide that now. Since that's mostly done, I'm going to go ahead and do the software side of things. So the first thing we need to do is get an operating system onto our board, and then we can install Klipper and set up CAN. So make sure that you do not have your CAN cable plugged in. Just leave that off for now, because you need to plug it in before you actually mount it. And we're gonna need to plug a USB cable into this anyway, so just leave it off. One thing to note is that the SD card on the M8P is kind of hard to get to the way I installed it. So either install Linux onto your SD card and plug it in before you mount your M8P, or mount it in a different way. So let's go ahead and get Armbian onto our M8P. One quick interjection is that I linked a document in the description that I put together myself that includes all of those printed parts, links to all the documents, everything you should need, including every command you need to copy and paste to get all of your software set up. So that way you don't have to look anywhere else except for that one document. Big Tree Tech provides an image for Armbian on their GitHub, but I prefer not to go with that. I just go to the Armbian website for the CB1, and I use this Armbian Bookworm CLI. I'm going to download that, and then I'm going to use Balena Etcher to flash it onto the SD card. They have a Windows and a Mac version of this program, so you can use it no matter which one you're using. Now that we're here in Etcher, we're going to select the Armbian image that we just downloaded, put it on our SD card, and let it do its thing. Once you've waited for the system to boot, you could have put in some Wi-Fi credentials into the image and it will automatically connect to your Wi-Fi, or you can just log into your router and find the IP address. I went ahead and did that, and you need to SSH into it with root. Once you get in with root, the root password is by default 1234, and now we're logged in. So you need to set up your own account. And there I went ahead and created my own account, went through all the startup stuff, chose Bash as my shell. And once you've finished doing that, go ahead and log out and log back in as the account that you just created. Once you're logged back in with your account, you're greeted with this nice BTT CB1 logo. And we need to install some dependencies, so that way we continue on with installing Klipper and Mainsail and those things. So go ahead and run this to update. Now that everything has updated with sudo apt update, we're going to run sudo apt upgrade. Once that's done, we'll install Python. Once that's done, we can actually go ahead and install Klipper, Moonraker, Mainsail, all that stuff. So I like to do this with KIAUH, Klipper Installation Update Helper. Find it to be really easy, so we'll go ahead and use that. First, run this command. And that just double checks the last two things that we just did. Go ahead and clone the Git to your system. Whoopsie, I just realized I had been logged in as root this whole time. That's not that big of a deal. But now that we actually want to run KIAUH, I went back and logged in with my own account. Let's clone the Git so that it's available for my account. And now let's run it. I find this to be very straightforward. You're just going to go into install, type in your password, and then you're going to install what it is that you want. What you really need is 1 and 2 Klipper and Moonraker, and then you can choose either mainsail or fluid for your interface. I'm going to install mainsail. And for the Formbot kit specifically, you're going to need 5 Klipper screen. The rest of this stuff you can install if you want, but really just go through 1, 2, 3, and 5. And I just choose all of the defaults. Well, it looks like the Klipper screen installation failed, and it's telling me what I need to install, so I'm going to go ahead and follow these directions. Install this, go ahead and delete this directory, and then try again. Alright, I actually got Klipper screen installed by just installing that thing it was missing and removing that directory and redoing it. So now we are done with KIAUH. So what we need to do is build the firmware for Catapult and Klipper for both the M8P and the EBB2209 toolhead board. So for this, I got most of my information from these 2 GitHubs, Frederick Asberg and Esoterical. Esoterical is in the Voron Discord. They're very helpful, but I wasn't able to get all the information I needed from just one of these 2. So I'm going to give you guys everything I did to get it all set up for what's included in the Formbot kit, which is the M8P v1.1, CB1, and the EBB2209 Raspberry Pi 2040 version of the toolhead board. First thing we want to do is actually install Catapult. We want to go to the Catapult directory, and then we want to make menu config. Now this will be specific to your board, and I'm showing you what is correct for the M8P v1.1. The microcontroller is an STM32. It is the G0B1. We are not going to build it. It is an 8 MHz crystal. For the communication interface, since we're setting this up for CAN bus, it's going to be CAN bus on PD12, PD13. It is an 8 kilobyte offset. And we're going to leave this CAN bus speed at this default 1 million setting, and we're going to make sure we do that for all of the other firmwares that we do. We're done with this, so we can hit Q to quit, Y to save, and it will write it. So what we need to do is make clean, and this will just clear out the directory, and then we hit make, and it will write the firmware file, so that way we can flash it in just a minute. Now that that's done, we need to cd our Klipper directory, and we need to do the same thing. So make menu config. Here we're going to enable extra low level. Again, it is an STM32. It is the STM32 G0B1. It is an 8 kilobyte bootloader. It's an 8 MHz crystal. Remember, we're doing CAN, so it's USB to CAN bus bridge. And the CAN bus interface is going to be on PD12, PD13. We don't need to change this. And again, remember to make sure that this is the same number for all of the firmwares that we do. We will hit Q, Y, make clean, make. Once we've written the firmware files, we need to actually flash them. So we're going to go into Catapult first, because that's what we're going to flash first. Now what we want to do is get our M8P into DFU mode. There's 2 buttons on your board right there in the middle of the screen. The left one is going to be boot, and the right one is going to be reset. What you're going to want to do is hold boot, press reset, let go, and then let go of boot, and it will be in DFU mode. Give it a second, and then type ls USB. And now we can see we have this STM or ST Microelectronics device in DFU mode. Great. Now we can flash Catapult using the ID that we see right beside of it. And at the end here, make sure that that ID matches what you just got in the previous command. And there we go. So you might get this error during download get status. That's okay. We know that it worked. So now what you want to do is go back to your board, hit the right button for reset, and then put it back into DFU mode. We will cd the Klipper directory. We can run ls-usb again. We can see that it is still in DFU mode. And we'll use this command where right here in the middle, it needs to be the correct ID, and it is. So we'll hit enter. And now we will flash Klipper onto the board. So now we wrote catapult and then Klipper firmware to your M8P, so your M8P is done. Now that it's done flashing Klipper, hit reset on your M8P, type LSUSB one more time, and now you can see that instead of seeing an STM32 device, we see this CAN adapter, and that's what we want. So now we need to set up the networking for CAN. So what you're going to do is type this command, which will edit a file in this interfaces.d directory called CAN0. You will paste this in, and the paste was a little messed up, so we can delete some of this extra stuff. And you want to make sure that this bit rate is the same number that you did in your firmware, and you want to make sure this TXQ length is long and it's 1024. So when we're done with that, we'll hit Control X, yes to save, enter to confirm that it is CAN0 is the name of the file. So that's done, let's actually put up the CAN network. So we'll do sudo if up CAN0, that'll turn on the network, and then we can query if we see our M8P with this command, and we do. We get detected UUID, it gives us the UUID itself, and we see application Klipper. This is correct because the M8P is now running Klipper, and we have the UUID that we can put into our Printer.cfg file. Now we can finally get to writing the firmware for the tool headboard. So we're going to go back into our catapult directory, and we're going to make menu config again. So now we need to set it up for the actual RP2040. So it is not an STM32, it is an RP2040. This flash chip, we're going to leave that as it is. We are going to use the 16 kilobyte bootloader. The communication interface is CAN bus. We're going to leave these as they are. And we make sure that this number is the same like we did for the two firmwares for the M8P, and we are done. We'll hit Q, Y, and we will type make clean, then we will type make. Once the firmware is done for catapult, we will do the same thing but for Klipper. Again, it is not an STM32, it is an RP2040. It is a 16 kilobyte bootloader. Communication interface is going to be CAN bus. These we leave the same, and last time we double checked that this number is the same, and it is. So we hit Q, Y, make clean, make. While that's running, what we can do is go to our tool headboard, and there is a jumper right here, or a header right here. We need to install a jumper onto that, so that way we can power this thing with USB. Once the jumper is installed, plug a USB cable into your M8P, and then plug it into the board. And now your tool headboard is powered with USB. Now we need to put this thing into DFU mode the same way we did our M8P. So we'll hold the left button, press the right button. This is actually kind of hard. I'll do this off camera. I'm just going to have to do it with some little Allen keys or something. Okay, I put the RP2040 into DFU mode, and we can check that with LSUSB. And we see our Raspberry Pi RP2 boot, which is good. That means we know it's in DFU mode. So let's CD our catapult directory. And now we can actually write the firmware. So we will use this command and make sure that this ID matches the one we just got from LSUSB. It does, and we'll hit enter. And now we have flashed catapult onto the tool headboard. So what we want to do is shut down the whole printer. We want to take the USB power out, and we want to plug the CAN cable in. There we go. I took the jumper off, I unplugged the USB cable, and I plugged in my actual CAN cable. I did not do the mount just yet. I'm just going to make sure this works before I actually secure everything. Once you're booted back in, you can use this command to check to see if the tool headboard is on the CAN network. Perfect. So we see a UUID for Klipper, which is our M8P, and we see a UUID for Catapult, which is our tool headboard. And again, just like we did with the M8P, you want to take note of this UUID because it is what you will put in your Printer.cfg file, so that way you can connect to the tool headboard. We want to CD our Klipper directory. We want to stop Klipper. And once we have that, we run this command, and we replace the UUID after the U with what our UUID is. then we can run the command. And Klipper has been flashed. So we can run this command again, and now we should see them both as Klipper, and we do. So now we can turn Klipper back on. And with that, we're done. So what I'm going to do is button up the CAN cable. I'm going to re-hook up my Klipper screen, and then we need to move into the Printer.cfg file. Once you've got it booted up and everything is buttoned together, you can load up your mainsail or fluid, whichever one you did. And now you need to get your Printer.cfg right. I can't provide you guys with just my Printer.cfg file, even if you got the Formbot kit, because you might not have plugged everything into the same ports that I did, and things are just going to be different. So I don't want you guys to just plug mine in, think it's going to work, and then end up messing your machines up. But I do want to point out a couple things. You can get the M8P, you can go to the M8P GitHub, and they have a config file that you can use. And then on the Voron GitHub, they have some M8P CFGs that you can start with. Use both and kind of piece it together for your build. You're probably going to have to go to the GitHub for the M8P, download the manual, look at the pin namings, so that way you can get everything right. And then you can follow the initial startup checks on the Voron design website, so that way you don't just immediately try to home your printer and mess everything up. Inside your Printer.cfg though, you want to make sure you define your MCU EBB CAN with the UUID we found earlier. And the same thing in your regular MCU, you'll define the UUID under CAN, so that way it can connect to both of them. Or else Klipper just won't be able to connect to your M8P or your toolhead board. With that, I'm going to make sure my Printer.cfg is correct, and I'm going to follow these initial startup guides, buzz my motors, get everything working, test my end stops, and then finally get this thing printing. For this metal wire that they give you to kind of give some strength to the umbilical cord, what I do is just generally see about how much I'll need, maybe about that much. And then I will snip this, and then I'll electrical tape it on, and then cover it all up with the included little nylon sleeving that they give you. I just finished wiring up the Nevermore, and if you want to use the fans that are included with this kit, there is a little thing for keeping the top halves together. That's right here, and you'll see it when you take the other one apart for your stealth burner. You have to clip that in order to get it to fit, in order to get this retainer piece to fit. Now I think that there is a different option, because they originally intend for you to not use the V6 version of the Nevermore. I don't think that was out, but there is this Sunon Honey Badger fan version, and I think it has some different tolerances for the actual fans themselves. Not only that, but Formbot includes these 3x Wago clips, and in order to use the V6 version, you need 2x Wago clips. So I just happen to have these, but if you want an easier time of doing it, you might want to use like the V4 Nevermore, which is what I think they intend for you to use with what's included in the kit. I did go ahead and run Input Shaper on this thing, and then I installed the parts from PCBWay, which I conveniently did not film, but I do have some pictures that I'll throw up on the screen. And you can see from these Input Shaper results that Input Shaper actually did get a little bit better, and my maximum acceleration in the Y did increase at least a little bit. So I used the exact same setup, I tensioned the belts exactly the same, and really nothing changed in between the two runs except those printed parts. So hey, I guess those printed parts did do something, so that's awesome. All right, the printer is in its final form, it's fully assembled, and I've been printing with it for a while now with really good success. I pretty much used the official Voron documentation and the Klipper documentation to finish the software and get it fully set up. I did end up using these annex style panel clips, which are really nice, instead of having to use T-nuts and bolts everywhere. By just using a little bit extra filament, you can print these clips so you can just take your panels off and on whenever you need to. After all that, let me rapid fire some stuff that I liked and did not like about this kit. I like the CAN setup. It might have been annoying to get set up at first, but now that I know what I'm doing, I really enjoy having just one cable. They give you a ton of hardware. I'm pretty sure you could build an entire other printer with how much extra hardware you have at the end of it. I like the mods that they included, like the big screen and tap right off the bat. And I definitely like the price. For less than $1,000, you can have this. And this is a great printer. Some things I didn't like. Some of the M3 T-nuts were a little frozen up, and that doesn't really matter since they give you so many of them, but that is one thing that kind of annoyed me. The foam tape that they give you for the panels is probably the only true low quality thing in this kit. I really would have liked to have seen some better foam tape. And the only other thing I don't like is just that the documentation is kind of lacking. With an LDO kit, I know that they have an entire supplemental document for what you don't need to do, what you do need to do, the parts you need to print, etc. I would have liked to have seen something like that from Formbot, but hopefully the document that I put together kind of solves that problem. And with that, let's wrap up this video. Thanks again to PCBWay for sponsoring this video and for getting those parts for me. As you saw in that clip, they did marginally improve my input shaper results. If you made it this far into the video, you might as well leave it a like. If you guys are interested in this kit or you've got one yourself and you've built one, definitely leave a comment and let me know how your experience went and if this video helped you. And remember, regardless of which kit you buy or which printer you're building, if you just subscribe, your prints will always come out buttery smooth. I'll see you guys in the next one.